Thank you, Bonnie and Barbara. And we have another really great speaker coming up, Morgan Bender, who will share Let the Hydrocarbons in Prince William Sound Talk, 30 years of environmental monitoring through Prince William Sound Regional Citizens Advisory Council's long-term environmental monitoring program. And just a quick thing, there's still sandwiches in the back, so please feel free to grab some.
Thank you, Tim. Okay, thank you for having me. It's a dream to present here in Whittier today. And I also win the prize for longest title. But that's because there's quite a few acronyms in this project. The first one, which I'll be reviewing, is the Prince William Sound Regional Citizens Advisory Council. Then I'll go over what LTEMP, the project that I'm talking about, is, what LTEMP has gone through, so talking about this environmental monitoring program, what do the results say, and what is the future of it? So first, about the Prince William Sound Regional Citizens Advisory Council, or council. I am here as a contractor of the council, but we do have Jana, who was tabling. She's in the cool red and white polka dot shirt. The RCAC is one of two citizen advisory groups that were formed after the Exxon Valdez oil spill. The other one is Cook Inlet, and they provide citizen perspective on oil spill infrastructure and shipping in Cook Inlet. But we'll stay focused on the Prince William Sound one. The Prince William Sound Regional Citizen Advisory Council works to accomplish the mission of citizens promoting the environmentally safe operation of the Alyeska terminal and associated tankers. So to do this, the council advises the Alyeska Service Pipeline Company, oil shippers, regulatory agencies, elected officials, and the public. And the council itself represents the people who live and work in the region that were impacted by the Exxon Valdez oil spill, including the communities in Prince William Sound, the outer Kenai Peninsula, and everything that was touched by the oil that you see in that map. So that's Kodiak Island, and they talk about issues relating to oil spill prevention and response. The board of directors, some of which are also in this room, are made up of representatives from these communities and key stakeholder groups in the region. And those who have the most to lose from oil pollution must have a voice in the decisions that put their livelihoods, resources, and communities at risk. So that is the mission of RCAC. Oh, thank you. Okay. So in Prince William Sound, the RCAC focuses on the Valdez Marine Terminal. So that's the terminus of the Trans-Alaska Pipeline. It's in Valdez. And the tankers that carry that crude oil through Prince William Sound and the Gulf of Alaska. It follows the oil as it moves through the facilities at the terminal. It's loaded onto tankers and shipped. For a frame of reference, there's about 4 to 5 tankers that are loaded every single week from the terminal. Okay, and our last slide on RCAC. The council's work is guided by a contract with Alyeska Pipeline Service Company and the federal law passed following Exxon Valdez in '89, and it's called the Oil Spill Pollution Act of 1990, or OPA 90. And the contract's council guarantees funding and the ability to do independent research and monitoring to review the industry's practices and regulatory practices. So that's pretty unique. We were talking about some other funding sources and how they might not be as guaranteed as this, and so that's a great thing about this group. So the responsibilities that the RCAC has are listed there in the bullet points. So providing advice and recommendations on policies, permits, and regulations, monitoring environmental impacts, that's the one I'm going to be focusing on, and reviewing the adequacy of oil spill prevention and contingency plans, as well as providing advice on terminal and tanker operations, policies, and practices. So, lots to do. Now I'm going to jump into what the project I'm talking about actually does. So this is the long-term environmental monitoring program. And it monitors the impacts from oil transportation activities on the biota in Prince William Sound and the Gulf of Alaska. So where the oil was spilled and where it reached. One aim of the program is to identify the sources of hydrocarbons in the sediments and mussels that are sampled, to provide recommendations for how to respond and mitigate potential oil spills, and to continually improve the program. And as you guys know from the previous slides, this monitoring program is a requirement under OPA 90 and the contract with Alyeska. So what do we actually do? The program is currently focused in the Port Valdez, where the marine terminal is. So we collect samples, sediment samples, at the terminal and also across the bay at Gold Creek. So the terminal will have a potential for hydrocarbons coming from the terminal to be found in the environment there. And then at Gold Creek, that's more of a reference site. So we collect sediments. We also collect intertidal blue mussels at different spots around Port Valdez. This is on an annual basis. And we also collect passive sampling devices, which should give us an idea of what kind of compounds are dissolved into the water that might be bioavailable to organisms. So this is the sediment sampling spot right outside the terminal. And here we go out every year and lower a device into the water that takes a grab of the sediments. I'll show you that device in a few slides. And what we expect to see here is what's coming out of the ballast water treatment facility at the plant. So when tankers come up, they're loaded with ballast for safety purposes, and then they exchange that ballast for oil. It's not in the same tanks anymore, so that's an improvement. But the ballast water is treated, mixed with stormwater from the facility, and then the outfall is right here next to our sampling location. This is the project manager, Danielle Verna, who works for the council, and she's sampling mussels, intertidal bay mussels at Gold Creek right across from the terminal. Many of you might wonder why we sample blue mussels. They're not Chinook salmon, but they are a wonderful indicator species that's used all across the world. So blue mussels feed indiscriminately when they're covered in water, and they collect whatever is dissolved in the water, and then they also don't move. So we're able to come back year after year and sample from the same community, and we know that those mussels have only been exposed to exactly what's there. So it's a little bit more reliable than fish species, for example. Also important ecologically and commonly found in Prince William Sound and downstream in the North Gulf Coast. So that's why we focus on mussels. Every 5 years, this program goes across Prince William Sound and samples mussels from several different locations in the southwestern Prince William Sound. Some of these locations were heavily oiled during the spill, and some of them are areas where we might expect a potential future oil spill to impact. So for example, Zykoff Bay on Montague Island, and then Sheep Bay is close, or excuse me, the stations that are closer to the eastern side of Prince William Sound have a little bit more current tanker activity, so anchorage areas, for example. And it extends all the way down to the north tip of Kodiak Island. So again, you'll see that that mimics the oiled areas from the '89 spill. I'll just flip through some pictures here. This talk was originally in celebration for this data set being 30 years old, so kind of a walk through history. A lot of the sampling that occurred in LTEMP was based off of Dave Janka's boat, the Auklet, so there are some really nice pictures of that. Even though the sampling might be pretty simple, collecting mussels off beaches, we need to do it in a timely fashion, so using helicopter access, and though there's some RCAC project managers that might be familiar to some of you collecting mussels in Sheep Bay. A sampling point in Ialic Bay, accessed by float plane. And then here is the sediment sampling that happens in Port Valdez. So we've lowered a grab, which is pictured in the upper right-hand corner. It's touched the seafloor, and now we're retrieving it again to get our sampling, our sediment sample. And you see it's sort of a big claw, and what it does, it scrapes up sediment and brings it up, hopefully undisturbed. And then we're able to collect a small portion of that sediment without leading to any additional contamination, using good field protocols, and send that to very advanced analytical chemistry labs. So much clicking. Great. Blue mussels are sampled in a similar fashion. We take multiple samples at every single site, so we have an idea of the biological variability in these samples and catch them at low tide. And because it's a very common species, we're able to have a really robust data set. And lastly, the passive sampling device. These are actually just sort of high-tech plastic strips that are deployed for a month at a time in some select locations. And what they do is take up a different profile of hydrocarbons, one that are dissolved in the water, and that gives us an idea of what the other organisms that aren't blue mussels might be exposed to. So we use those 3 different sampling matrices to get a pretty good idea of what the hydrocarbon exposure might be in the sound at those select sites. So this now has 30 years of data. I think we talked a little bit about what a long-term data set was in the, the octopus presentation. And now you guys know how incredibly unique it is that we have 30 years of hydrocarbon data in a place like Prince William Sound. So 30 years of data. I know for a fact that there are over 238,000 measurements in this data set since I'm the data manager at the moment. There's been 13 different experts involved, in addition to everyone on the Prince William Sound Regional Citizens Advisory Council Scientific Advisory Committee. And a lot of these people have been with the project since the very beginning. So there's a lot of continuity and a lot of expertise. It's been analyzed at least 16 different times, so people are paying attention to this data. There's been 5 different analytical laboratories involved across all of the US, from the East Coast to the West Coast. So pretty high quality there. Using 3 different transport methods. We're out on boats, float planes, and helicopters. And for every single sample that is collected, there's over 160 compounds that are analyzed. So it is really a treasure trove of stories and data. And I'm just gonna go over now a little bit of the development of the project. So Exxon Valdez was in 1989. I was born shortly afterwards. No relation, I don't think. The Oil Pollution Act of 1990 and the formation of the council. And then the LTEMP program started in 1993, shortly after. It was first analyzed 5 years later in 1989, and then it went through sort of a revamping reduction, which essentially just changed the sampling timing in 2010. In 2016, we added the passive sampling devices, so we had an idea of what was dissolved in the water. And in 2020, the project expanded to include transcriptomics, which is small changes in the biology of the blue mussels, so we could have an idea not just of what contaminants were collected in the tissue, but how that actually affected the organism. So that was a big step. It's not included every year, but there is some ongoing work with that. And in 2023, we celebrate 30 years. So 2024 will be 31. But what else is going on in the background? When we try to look at these compounds and their levels, what else do we need to consider? So the peak oil production and volume sent through the Trans-Alaska Pipeline was in 1988. I have a slope that's not accurate there for what's happening, but it's going down. That also means that there's reduced output from the ballast water treatment facility, so that's a good sign for the potential environmental impacts. In 2015, we have some improved environmental measures. When we fully phased out single hull tankers, I'm sure some people can speak more to that if there's a question on it, but that essentially means that the oil and the ballast water doesn't mix at any point, so that shouldn't have to be treated by the ballast water treatment facility. They also upgraded the ballast water treatment facility so that it's more effective, but there are also several terminal spills that have occurred, most recently in 2020, and there has been some other spills in the Sound that might show up in this data set, including some diesel spills at our reference site in Gold Creek. Meanwhile, there's been warming and freshening trends in Prince William Sound, which impact the behavior and fate of these compounds in the environment. We have things like cold periods and marine heat waves. So really, it's good to put this all in the context of what we're seeing. And now I'm gonna jump into the data. So this is the concentration of polycyclic aromatic hydrocarbons, which are a small, small group of what we find in crude oil, which is made up of thousands of different chemicals. These guys are supposed to be a nice summary of the toxic compounds in crude oil that especially affect aquatic organisms. So the y-axis here is in nanograms per gram, that's parts per billion, and here we're looking at concentrations in the sediment. The purple line is at the terminal, and the gold one is at Gold Creek. I tried to make something obvious. And what we see is there was quite a bit of variability for the first 15 years of the study about, and then in the mid-2000s, things kind of calmed down, and at this point, we're looking at what the chemical lab's level of detection is. So the differences that we see at this point are really just what we can detect. So we see hydrocarbons, but they're almost as low as they can get. If we look at what the blue mussels are experiencing, we again have the same unit of measuring here in a group of hydrocarbons that are known to be toxic in the parts per billion range, and then all of those squiggly colorful lines are different sites around Prince William Sound. So again, a lot of variability in the first few years of the program, and since then, just some minor spikes, and they correspond to essentially every time you have an oil spill. So here in 2016 and 2020, we see spikes near the terminal where the oil spills occurred. And that already shows the utility of the blue mussels, that they respond quickly when there's oil in the environment, and then they're actually able to process that and eliminate the oil from their tissues. Okay, but why are we focused on hydrocarbons in the first place? Hydrocarbons are toxic to aquatic life, and the group of hydrocarbons that I showed you the data for, the polycyclic aromatic hydrocarbons, cause developmental effects, cancer, reduced growth and reproduction, changes in fish's swimming ability, and death at higher concentrations. But in the environment, PAHs are always found in a mixture, and they can act on many different pathways in aquatic organisms. Here is kind of the brand new research direction that is being pursued as far as aquatic effects on organisms. And I would say almost all of this work comes directly out of Exxon Valdez aftermath. So this science was developed with some of the first responders to Exxon Valdez and has since skyrocketed. And what we're seeing is that larval fish are especially sensitive to exposure, to oil exposure. And they look like this with, fluid accumulated around their yolk sacs, and we actually find that that's because their heart is impaired in the development. So they're not able to move that fluid around, and therefore suffer these developmental effects. Some of them survive and grow up, but then have less ability to evade predators, for example, or have trouble swimming, reduced growth. So we have pink salmon in the black, and then herring in the gray, both species that are really common in Prince William Sound, and they have now been studied extensively, and this research is published. And then I'm going to unabashedly present some of my own work. This is an Arctic cod larva. They're not present in Prince William Sound, but focus more in the Arctic, a circumpolar Arctic species in the Chukchi and Beaufort. So this is a control individual that was reared under no oil exposure. And then if you expose them to 0.2 parts per billion, so on a level that we didn't see in the previous figures, they hatch out of their eggs looking like this. We call it the Darth Vader phenotype. So they have deformed eyes, deformed jaws, deformed spines. They're not able to feed, and these guys actually die of starvation. So that's a lot of the motivation for my research. And so if we take what we know from these lab studies about the sensitivity of organisms and we compare that to what we see in the L-temp results, looking at hydrocarbon concentrations, we see that the sediments present a low risk of chronic effects to aquatic life if we use an EPA benchmark. They're just 1% of what would be considered toxic, even at the terminal. Intertidal mussels, we see again low risk. These concentrations are likely too low to elicit adverse effects in the mussels or in organisms who might consume the mussels. And the passive sampling devices, which measure the concentrations in the water, also reveal low risk. So even when we compare those levels to what we use in the lab to that lead to like cardiac effects in the animals. Great. We're going to move on to the next section. I see that I'm talking very fast, so I can slow that down. How do the hydrocarbons reveal their sources? If we're going to let them talk, what are they going to say? So to answer this, we have to go into some more minute chemical details. The first tool that I use here is looking at the patterns and ratios of the different compounds. So here we have a specific hydrocarbon parent group and its alkylated members. Those are on the x-axis, and then a concentration on the y-axis. And if it elicits this nice rainbow pattern, that means that it's of crude oil origin. That can be crude oil, that can be a natural seep. Crude oil is a naturally occurring compound. It can be from coal and peat sediments, which we do have in Prince William Sound. And the second most obvious trend is when there is a waterfall occurring between the parent compound and its alkylated isomers. And this is indicative of pyrogenic origin. So think fire. We have combusted fuels and exhaust, forest fires, creosote. And so these can also travel great distances, right? You have a forest fire in Canada, you might see that same signature in the hydrocarbons downwind. The second tool that we use to identify the source is using petroleum biomarkers. And these are compounds that don't weather quite as much as the other compounds in oil, something called recalcitrant. And so we essentially analyze a whole suite of these chemicals that are found in crude oil, but also produced by other organisms, and then match those up with known sources. So here I have a sample plotted in gray. Those are the gray bars. And then I've overlaid some known sources. So we have effluent from the ballast water treatment plant. We have the terminal spill, and we have Northstrope crude. And if I see a match like this, that tells me that there is quite a strong signature from these general sources. So Alaska North Slope crude origin. All oils look different, different sources look different, and unfortunately it gets a little bit complicated when there's not just one. So if I apply these same techniques to our samples, I found that in 2023, the sediment samples taken from right outside the terminal had a signature from the terminal. Nobody gasped. I was waiting for that. If I look at what's going on at Gold Creek, we see that they had a mixed origin. So I see both petrogenic of oil origin and also some combustion sources. So this is where it gets more difficult to untease what it is. So you do see some indications of other kinds of human activity. Thank you. Great. We see low levels in Prince William Sound. Why are we still out there measuring them? Long-term monitoring is a key part of the Council's mission, promoting environmentally safe operations of the terminal and associated tankers. Number one, it's written into law. The second one is to detect change, injury, and recovery in the event of a spill, and we have plenty of examples of how that has happened in recent time. 2020, for example, we are able to see that signature and those increase in concentrations and their subsequent fall. And the third point is that it provides a really robust independent data set. So this is not going to be fluctuating with funding opportunities or political regimes or a grad student graduating. This is something that is going to continue and is available for future analysis, whether that's by myself or another contractor or another researcher. It is really an incredibly unique data set. So what are we doing with it? We are in the process of making sure that it's quite accessible to the public through the Alaska Ocean Observing System. It's hidden in a few deeper pockets of the data archival world at the moment, but we're working to get it up onto this specific site so that anyone could go and download this data, and you can analyze it for yourself. You can use it for a project because it is such a unique data set. And that's part of the data sharing and data availability. That's something that's very unique about this project. We annually revise and modernize the project. We look at the data, we make sure that there's nothing strange with it, we present the results to the scientific advisory committee, and it goes through review. And it also gives us a strong base to work on other projects, like looking at other compounds that weren't captured in that 160, like oxygenated pHs, for example, or looking at biological changes in the organisms that we study. So that allows us to jump out and pursue new project opportunities, but still having this really strong core base in environmental chemistry. And again, it will continue as long as oil flows through the pipeline and the Valdez Marine Terminal exists. Yeah, I think I'm done now. And with that, I can take questions. Again, my name is Morgan Bender, and I'm here on behalf of myself, Fjord and Fish Sciences, and the Prince William Sound Regional Citizens Advisory Council, who I contract through. Hopefully I didn't put that many people to sleep.
Are there any questions in the room for Morgan?
Ooh, yes.
Go ahead. Yep.
From the graphs where you were showing that there's a lot higher variability in your data points in the first chunk of the program, have your sampling methods changed at all throughout, or is that truly just 100% a reflection of the fact that it was closer to when the Exxon Valdez spill happened?
Good question. They haven't changed that much. It's a pretty simple sampling procedure. Collect mussels, ship them to the lab, collect sediment, ship it to the lab. The labs have changed over time, but they do not correspond with those larger peaks and valleys. There has been more variability. I didn't show that in the graph because it gets pretty wild. But there has been more variability in the past, but also, more oil going through, different practices for oil pollution prevention. But yeah, really great question.
We're up against our break. We'll take one more question. Dale?
Yeah, I might mispronounce the pyrotechnic sampling, where you said it was like creosote, burn fires and stuff. Does that also include exhaust, like from diesel engines, outboards, ships? Does that go into that category as well?
Yep, that does. Yep, the pyrogenic. And one interesting thing that I didn't present here, but the blue mussels, which you wouldn't normally use for oil spill forensics, which was like the little eyeglass slide that I showed you, because they have their own processing. They don't absorb everything that's available or everything that's out there. They only absorb what's available to them. And they also have biological mechanisms which break down and eliminate things. So you're sort of seeing a skewed version of what's there if you were to look at the blue mussels. But we do take samples at the red light right outside the Valdez small boat harbor, and those compared to what you see at the terminal, it is pretty wild to see the difference in the chemical profiles of those mussels in particular, because they are exposed to all of those different compounds that people use on their personal boats, and there's maybe not the same reporting or cleanup or awareness in the harbor situation versus what you see at the terminal. Mm-hmm.
Thank you, Morgan.
Sure.
The pro move of the day is giving that talk with your daughter.
Yes.
Yes.
Thank you, Senya.
So cool. Thank you, everyone. Sorry we didn't have time for more questions with all of our speakers, but we're going to take a short break and get back at 3:30. As I said, there's still snacks and sandwiches in the back, and we also have the evaluations and surveys that are online or hard copy in the back of the room, so you can help us understand how to continue to improve the symposium. So thanks to all of our speakers. Let's take a break.